of going to solve this question, flip columns for maximum number of equal rows. So let's get straight to the point what this question wants us. So I've just picked the test case 3 in which, as you can see, we have given a matrix, a 2D matrix. I mean, obviously it's going to be 2D anyway. Yeah, so right now as you can see, we have 0, 1 and this matrix always going to contain these two numbers. So the question wants us to give the maximum number of rows which have the same value. So as I can see right now, I can see only one row which has the same value. So I'm calling it 1. I'm gonna return it. No, bro. If it was that easy, that it wouldn't be a medium type problem. So, so the question in this question, they want us to give the maximum number of rows by inverting the value of column. So let's say I'm at right at this column. If I try to invert the value, it's going to become 1, then 0, and then 1. Now if I try to count the maximum number of rows which have same value, it's gonna be these two, and it's gonna 2. And in the end, we're gonna return the value 2. As you can see right over here, the output is 2 for the test case 3. So, I mean, how can we do this? I mean, there is a brute force way in which we're simply going to just follow this pattern in which first we're going to invert this, then gonna check how many rows have same value, then this, then this, then this, and then this, and then the last one, this. But the last one doesn't make sense. I mean, after inverting all the values, it's gonna make the same matrix again. So, I mean, this thing is kind of stupid. So, I mean, do we actually need to do the brute force way? No, there is a way in which we can solve this question. I mean, it's kind of hard to get it how to just have this kind of thing, but I mean, we can do in this way. So let me just show you what this question can be done and can be easily tackled out. Always, there is a trick behind to solve any Leetcode question. So instead of considering the whole matrix, what we can consider just right now, for an instance, we can just consider two rows at a time. So as you can see or you can observe that these two rows are not equal. Even if I try to do a single inversion of it, it doesn't going to make any sense. It's not going to equal anyway. But what if what if I come at this point and I try to do a single inversion over here? If I try to do a single, I mean the previous value is 1. If I try to do a single inversion right over at this place, it becomes 0 and 1. So I mean, in this way we will get to know that we have two rows which have same value if I try to do inversion. So when this is possible, so basically it is only possible in these cases if these two rows have the same value, or these two rows have the exact opposite invert values like this. In these case it is possible. Or it could be another case in which these two rows are kind of like this, exact invert to each other and one value like this. So if I try to do inversion of it, it's going to become like 0 and 1. So these are the cases. In this way, we can find out that these are some of the values. If I try to do inversion without doing a brute force way, I get to know. So there is an algorithm which is running behind it to get to know the answer, and it will exactly show the answer which you were looking for. So let me just show you. So instead of doing this, we can just simply use a hash map and a counter variable. So let's say I have a hash map right at this place. Let me just say so, pick up this color. So I have this hash map. Right now I'm at this place 0 0 comma 0 comma 0. So I'm gonna keep this thing as a, what do we say, key 0 comma 0 comma 0, and I'm gonna increase the value to 1 since I've encountered this kind of pattern 1. Then once I reach at this second row, what I can see, it is 0 comma 0 comma 1. So it's gonna store the key value 0 comma 0 comma 1, and in Python we're gonna store this value as triple. I mean, we could store it as string, but it doesn't matter anyways, since in dictionary we want immutable data type. So yeah, that's our tuple. Then after that we're gonna increase the value of 1. Now here's the catch. Once we try to reach at this point, we want our tuple matrix to be biased to 0. So biased to 0 basically means that if I encounter any initial value of 1, I'm gonna invert the whole number like this. I'm gonna store it right over here. But once I look at what I can see that this kind of key already exists, and which means that I just simply need to increase the value. Now once I've reached the end of it, what I can observe from the hash map, I can see that there is a maximum key value pair whose value is 2, and this 2 is kind of equal to our answer. So there's the main iteration and the thought process behind it. So let me just code this thing up. So let's just consider this. What do we have right now? I want to iterate over the rows in what? In the matrix. Cool. And I need a hash map. Let's gonna say it's count. So for the time being, what I can do, I can simply increase the value. I mean, first of all, I'm gonna convert the row into tuple. So row t equals to tuple of it, and I'm gonna convert it. Once I convert it, I'm simply going to store it to the map. Row t and increment it by count of row t, I mean dot get. Since there is chances that this row t doesn't exist in our hash map, if it doesn't exist, we're going to return 0, otherwise it's going to return its value. Now in the end, I'm going to return the maximum value of the count dot values and the maximum of all the values, which I've just shown you in this example. So I mean, just like told you that we are main concerned about the zero bias instead of one bias. So if I encounter any value, let's say row first value, if it is equal to 1, I mean, it's going to be run iterate anyway if it is 1. So if I encounter this kind of value, then I'm going to say my tuple is going to be inverted value, since we more consider the zeros biased value instead of one biased. So let's say if the value of n is 1, I'm gonna return 0 0 right at this place. And if the value of n is, what do we say, 0, it's going to return 1. for n in my row. So that's how we create opposite, just opposite of this thing. And if I try to run this code, hopefully this thing will work. And let me just zoom out for you guys, and let's just run this thing code up. Hopefully, yeah, as you can see, it worked perfectly fine. And that was a pretty small code for this medium problem quotient, but yeah, we did it anyway.